Good day. I think it's easy for me to say good day to everyone. All of SIDS. In the Caribbean is good morning, very early morning. In the Pacific is good night. And in the Gulf is good afternoon. Welcome to this webinar on energy management and energy audits in small islands developing states. My name is Ellsworth Dakin. I'm the Caribbean focal point. I'm located in St. Vincent in the Caribbean. And I want to welcome all participants here today on this webinar. This webinar is hosted by IRENA under the SIDS Lighthouses Initiative, and it builds upon the four webinars that were held previously in Grenada under their capacity program. I want to welcome you this morning and introduce you to Mr. Amjad Abdullah, and he will lead this webinar with some opening remarks on behalf of IRENA. Amjad is the head of partnership in IRENA, and I want to welcome you this morning to open remarks. Mr. Amjad.
Thank you very much, Ellsworth. Friends, distinguished participants, ladies and gentlemen, a very good day. From the headquarters of IRENA, Abu Dhabi, at the United Arab Emirates. It is an honor to welcome you to this two-day webinar on energy management and energy audits in the small island states. At IRENA, we recognize the crucial need for coordinated partnerships to successfully deliver technical assistance and capacity building support that will enable small island developing states to meet their national energy goals and climate commitments under the Paris Agreement. Implementation of NDCs forms a core part of IRENA's support to SIDS, and the focus of today's on strengthening capacity to scaling up efforts on energy efficiency has been one of the top priorities of SIDS Lighthouses Initiative. Based on the recommendations of the IPCC, IRENA's latest World Energy Transition Outlook 2022 report endorses the pursuit of an aggressive energy efficiency strategy coupled with increased renewable energy deployment as the most feasible option to halving the emissions by 2030. This webinar targets homeowners as the residential sector is a major contributor to energy consumption and has one of the highest potential for saving energy through energy efficiency measures. Improving residential energy efficiency is consequently widely recognized as one of the best strategies for reducing energy demand, increasing the security of energy supply, and meeting the ambitious climate change targets set out by SIDS under the Paris Agreement. In addition, IRENA has recognized the critical role of youth in driving the energy transition, which can only be enhanced through their increased participation in policy dialogue, decision-making, awareness, and capacity building. Dear friends and colleagues, by lowering energy use, proper energy management practices, and energy efficiency interventions can help to reduce monthly energy bills and makes energy more affordable for businesses and families. Furthermore, it can also create opportunities for developing local industries, job creation, and strengthening SIDS economies and livelihoods. To this end, you will learn about the fundamentals of energy as well as the benefits of energy conservation and energy efficiency. It will also equip with the knowledge to conduct your energy assessments at home so that you can identify most effective strategies to reduce your energy consumption. I encourage you all to actively participate in the discussions and exercise that will ultimately help you to lower your electricity bills, which will in turn benefit you, the environment, and the globe and your country. This event builds on 4 webinars and face-to-face training that we have held under the Grenada's capacity building program for energy management and energy audits, and aims also to share best practices and lessons learned amongst all SIDS. I do hope that you will also benefit from the 2 manuals that have been developed to supplement these webinars, which outlines the energy audit methodology and can be used as a reference document for both technical and non-technical users beyond this event. Let me also close by extending our gratitude to the colleagues at the Energy Resource Institute for their contribution to the development and execution of this capacity building program. With that, I thank you and I wish you a very successful training over the next 2 days. I thank you very much. Over to you, Elspeth.
Thank you, Amjad. And just to echo what Amjad has shared with us, I think we could all agree that we are, as islands, we are most vulnerable to climate change. And we also quite dependent on fossil fuel. I want to particularly say at this point in time, what's going on with the world in terms of the war and the oil prices. This webinar is quite timely, and it is quite important that we learn about energy efficiency, in particular within our homes. So I think this webinar is quite timely indeed. I want to introduce you to our consultants who will be with us for the next 2 days. And they are from the Terry Institute. The Terry Institute is an institute located in India, and they are a research and development institute. They were established in 1974 as an informative center on energy issues. And over the following decades, it evolved into a research institute where policy, technology solution transform people's lives. I want to introduce you to Dr. Rao and his team, Vijay and Sharma, who you will hear over the next 2 days. Dr. Rao, he has over 25 years experience in energy efficiency and renewable energy techniques. He has a master's degree in mechanical engineering, and he has an extensive experience within this field. Dr. Rao will conduct the first session on introduction of energy and energy concept, electricity concepts. Dr. Rao, over to you. Just for the participants, while Dr. Rao is setting up, because of the number of participants this morning, today, we were unable to give access to all the mics. So if you have any questions during the course of the webinar, please feel free to raise your hand and share the questions on the chat box, and we will address those questions. If you're ready, Dr. Rao, we can't hear you. If you're speaking, you need to unmute your mic.
Also, you're able to hear?
Okay, thank you.
Okay. Yeah.
So welcome, and over to you.
Yeah. Good morning. Yeah. Just a minute. Slide. Slide. Slides. Yeah, Ms. Elspeth, you are able to see the slides? Hello?
Yes, we can see your slides.
Okay, yeah. Good morning to all the participants. So we are next 2 days, we are going to have a session mainly on the technical aspects of how the energy saving can be done in the homes as well as for the youth in the schools or education institutions where it is a small consuming identity. So we are having this particular session, and the first day with the objectives of this particular program. Then we have fundamentals of energy, energy efficiency, and energy conservation, and understanding of our home electricity bill. It is basically with reference to the Grenada as considered as an example. We are going to drive the electricity bill and what are the components and how the calculations to be done for the home electricity bill we have made. And there is a energy conservation measures in homes, what kind of measures will be there, and how one can evaluate the measures, and the savings can be defined, and how one can calculate the savings, energy savings for their homes and the schools. Some case examples has been given in the first day course, and a few small questions and answer session at the end of the first day session we have prepared. Now, yeah, as a background, it has been mentioned that the capacity building program has been designed with the emphasis on Grenada as a country. And it is mainly the Grenada has realized that the energy management and energy auditing principles, if they can implement in their sectors, mainly from the residential sector and industrial sector, commercial sector, there is going to be a significant savings in terms of cost benefits to the end users. So they have identified the capacity building as a tool. And this particular program has been designed how one can take up the energy audit principles and learning the energy audit principles and practicing those principles in their daily life, and the habits and behavioral changes, how it will impact. Those are the aspects which has been defined in this particular program. And we have carried out 4 webinars till date. The first webinar is on home owners and youth in the similar fashion of next 2 days program, today and tomorrow. And the second webinar we have conducted with the focus on hotels and the financial institutions. Third webinar is with the government ministries and statutory bodies and training institutions as a focus element. The fourth webinar, which last month we have conducted for the commercial and industrial sectors. And the face-to-face program is a 4-day program in one of the resorts in Grenada we have carried out, and a practical session is there for 1 day, and how to do the assessments and calculations on 1 day we have done, which has concluded 2 weeks back. And today we are having the 5th webinar on this particular series of capacity building program. So now the first session in this is the fundamentals of energy efficiency and energy conservation. So one should know about the fundamentals. Every day we use energy for carrying out various works, which you can see for all the age groups of the people. They use for the various activities the energy need, which is conversion of the biological energy into the useful work for the human activities. So under this one, the basic definitions for the energy is the ability to do the work is the first concept for the energy. Then we have the energy which is transferred for moving of the any of the component and any of the mass to a certain distance, or carrying with the hands, or throwing with the hands. These are all the the mass which we are keeping it some distance we are making. That is nothing but the work. And the energy, which is nothing but the rate at the time period of energy what work we are carrying out, is nothing but the power. So as a definition, if you can see, the power is nothing but energy divided by the time, which is a joules per second, which is also equivalent as watts in electrical terms. So energy is nothing but power into time. If you can multiply the power with the time, which will be the energy, that is nothing but kWh in terms of electrical energy. Now we have 2 parameters, because our focus mainly on electrical energy in the homes. Even we use LPG for the cooking, and even the vehicles and other things we will use the diesel, gasoline we will use, but still our main focus in this particular capacity building has been much emphasis has been given for the electrical energy. So the electrical energy, we have a kilowatt, that is the capacity of any equipment. The unit is measured the amount of power needed to operate any equipment. That is definition of kilowatt, where 1000 watts is the equivalent of a kilowatt. And we have a kilowatt hours, which is a measure of electrical energy. If you are consuming for 1 hour, then it will become kWh. The kilowatt multiplied by hours, that is with 1 hour, it will be 1 kilowatt hour. And the other thermal energies, joules, which is Newton per meter. Newton is a mass and meters is a distance of movement. And the watt is volts and ampere, that is a watt. So these are the fundamental for the energy. And we have forms of energy where different forms of energy has been used in consumed in daily life. We can see there, if you can categorize them, it is a physical energy for doing the work, and thermal energy, which is the heat energy, where from the fossil fuels will convert and will get into the energy for full heat. And we have electrical energy, which is mainly for running the equipments, the very we can say efficient form of energy, which can be when it is used. So physical energy is mainly for doing the daily works, routine works, and physical movement of the objects, whereas the thermal energy is mainly we can use for driving the vehicles, converting the fossil fuels into the moving cars, vehicles, and even cooking and water heating, these kind of applications. And the electrical energy, we have lights, fans, air conditioner, running daily appliances. These are the forms. And we have different forms of energy, which is from how it has been obtained. Chemical energy, which is released from the chemical bonding of the components, either fossil fuels or biomass kind of one. And electromagnetic waves, which is natural available waves, which is carries the heat from the sun to the masses. And we have a mechanical energy, which is stored in tension and compression in the materials, where the simple example is stretching of a rubber will release the energy which is stored in that form. And we have electrical energy, which is conversion from the other materials. And we have a thermal energy from the geothermal and the solar thermal energies as examples. So these are the different forms of energy which everybody knows. Then we have conversion of electrical energy. Main sources of electrical energy we have from the fossil fuels, we have from renewables, we have from geothermal, and even from the hydro. All forms of energy which we can convert into the useful form as electrical energy, which can be transmitted very easily from one place to other place, and which can be, with the technology what we have today, it can be used at the end user form in different versions. And even where latest one is the EV electrical vehicles, which has been transportation mode, which is considered to be the more efficient and easy way of using the electrical energy. So the forms of energy, if you see comparing all the forms, electrical energy is a very easy and which is a very efficient way of conversion of the energy to the usefulness. So when electrical energy, when we are seeing, which will have a different component till reach to the end user. End user is a home or school or college, whatever you can take. From the generation point, from the if you are generating the electricity at one particular place as a power plant, from either it can be a solar power plant or a thermal power plant, but when it is reaching to the end user, there are three components of power which will be flowing in the conductors which we have, where the active power is a kilowatt, where the useful form, useful energy which will be there in a terminology of when beer you are poured in a glass, in a mug, we can see the active this one, but there will be a foam which comes out as a type of inefficiency. It is like a waste, but the foam is must. Without reactive power, the active power will not come into the picture. So as much as possible, the reactive power should be minimum. Then you can get best active power in the system. That is nothing but the kilowatt power, useful energy which we can get. And at the same time, the combination of both the active power and reactive power is nothing but apparent power as a total power in the system. So when we can see how the power rating of the system, the input power and active power for any appliance what we are giving, which will be used for doing the activity. Mainly, if you can take any kind of a product as a refrigerator or a air conditioner unit, which will have a tag on the product, whatever the rating, how much is the capacity of that particular equipment, means which can draw the power capability of that much of kilowatt for the particular equipment. If that particular equipment has been operated for a period of 1 hour, then we can get the energy consumed by that particular equipment. If you say it is a 1 kilowatt or is 1000 watts, then if you are operated for 1 hour, then it will become 1 kWh. The 1 kWh is energy which has been consumed by that particular appliance, will be recorded in a meter, which is there for the individual equipments, or it will be generally, it will be the utility meter, which will be there at every house or school or college. Now, our measurement for the energy in the electricity bill, or when we are doing the calculations, everything it should be in kWh as a terms. The active power multiplied by the 1 hour, which will give the time. Now, we have what is the difference between the energy efficiency and energy conservation? The energy efficiency is using energy to provide a service to any of the appliances or equipment. How we are converting the input power and how much will be the output, the loss which has been occurred, that is been minimizing the loss, which is nothing but the high efficiency. When it is energy conservation, which is nothing but the behavior of the people, the type of activity what we are doing, which is consuming a less energy, then it is called as the energy conservation. The basic difference between the energy conservation and the energy efficiency, if you take, energy efficiency is an integral part of energy conservation. But energy conservation is a behavioral change. Basically, how our habits, how we actively do our works, how we will choose our appliances, equipment, that itself will consuming the less energy, which is nothing but the energy conservation. Now, like if you have a tube lights or any facility, house or any classroom or anywhere, if you are turning off the lights when it is not in use, that is called energy conservation, because you are actively, your decision you are taken that to turn off the lights. That is nothing but energy conservation. Now, you have incandescent bulbs or high power consuming devices like fluorescent lamps and other things, which you are replacing that with the high efficiency LED lamps, which are available in market today in most of the places across the globe. So that is replacement of high efficiency lamps is nothing but the energy efficiency measure, which you are taken kind of, where you are investing and you are bringing the high technology and high efficiency product into the thing. Same way, if you have an air conditioner where you are setting the temperatures higher than the normal requirement, even at 22 degrees is considered to be a nominal one. But if you are sacrificing something and based on the ambient conditions, based on the type of operation, even 24 degrees you are setting and the comfortness you are feeling, then it is nothing but you are taking a participatory role in energy conservation. Same way, if you are having a inverter-based air conditioners, which is available in the market, replacing with the window ACs and old air conditioners, manual switch on and off air conditioners, then it is high efficiency product you are integrating. It is a high efficiency systems you are taking place. So these are the simple examples, daily life, which we see the difference between the energy conservation and energy efficiency. The same way, you can see further a few examples where the energy efficiency is nothing but technological improvements and advancements in the particular products, like which we see normally the high efficiency lamps, LED lamps, and ceiling fans, which is latest, which is available as a brushless DC motors, where the savings to the conventional fans are around 50 to 60% by these ceiling fans. and inverter based air conditioning systems, low refrigerant, low area also, where the high performance air conditioners are available. And in cooking, we have a induction technology where the amount of energy used for the cooking of any product would be less by in terms of, but the induction technology is the electrical stove. So these are the few for the technology wise, the energy efficiency. Then we have energy conservation, where the behavioral and habits of the individuals, which leads to the less energy consumption, which is energy conservation. Like use of staircase, when even you have a lift, but you are using a staircase for going up and down, that is nothing but energy conservation. And using of bicycle, where the human energy has been converted for movement from one place to other place. And you have a cooking stove where you have multiple burners, where you are choosing a correct size burner for a vessel size, the smaller burner for the correct size of the vessel. Then it is nothing but you are consuming a less amount of LPG gas for cooking. Then it is energy conservation. And also there are a lot of small tools are available, even like a example of mobile chargers, which is regularly everybody is using now mobile. And we have a charging facility where there is a solar battery backup, solar chargers are there for using the mobile charging. If your behavior means you are adapted to a solar battery chargers, recharging of batteries by solar, or using a torchlights of solar. So when you have taken a call that you are using a renewable energy product for your regular small uses, that is also energy conservation.
But sorry, Dr. Rao, I'm not sure. I just saw a question that I'm not sure if if everyone is seeing your slide.
Yeah.
Is everyone
yeah
seeing this slide, or is it just the panelists? I'm not sure if it is shared.
Yeah, you're able to see.
Okay.
Yeah.
I just wanted to verify because I saw a question. Okay, thanks.
Okay.
Continue. Sorry.
So now, in the same tune of energy efficiency and energy conservation, we have different products which is available in market. Like simple example as a washing machine, where we have a front load and top load washing machines, which will be there. If you're saying using the front load washing machines, which takes lesser power and less water, which is being consumed by the washing machine, which is a more efficient one. So you can choose the front load washing machine, which is efficient. And at the same time, like you have a ironing of clothes, which is every day people will be doing. If you can accumulate for a 2 or 3 days or a weekend, if you're accumulating all the clothes what you have washed, and one instant if you are doing, rather than doing in a multiple times in a small quantity, there is also a energy conservation habit, behavioral change. So these are the simple examples which we come across in our daily life. So as we have seen, the technological intervention, which is nothing but reducing the amount of energy required for any product or service, that is energy efficiency. For the same amount of output or service we're getting from the little bit of smaller amount of energy. And energy conservation, which is nothing but the behavioral change, switching off the lights and use of less rated power equipments for the same appliance. So as I told, energy efficiency is an integral part of energy conservation. Then energy management, which is a series of steps where you can adopt different stages, and even like maintenance of the appliances, equipments at home, and the kind of actions what we do, and the knowledge which we have to sharing with the other family members, children, and sharing what it is. All these a part of the energy management at each and every level. So these are the three elements of energy management and energy conservation and energy efficiency. Now, another example is like if you are having a lift and staircase, which I told, if you can see, like if you are using the staircase, it is energy conservation. And optimally, if you have a lift and instead of single person moving in a lift movement, if wait for a minute and 2 or 3 people, optimally what it has been designed, if you're more number of people are using, then it is an energy efficient use. And energy intensive is nothing but if a single person using the lift for movement, that is an energy intensive process. Same way we have for the transport kind of one, where if you're using a bicycle for the shopping of a small quantity or something, it is a energy conservation. And if you are using a smaller car, whichever, if it is available at your house, if you're using for the modest shopping, it is instead of using a bigger car, pickups and other things, it is an energy efficient method. And energy intensive processes, even if you're using for a movement of a small equipment, a big SUV kind of vehicles and all, these are energy intensive process. So it is based on the availability and the equipment, one can decide whether they want to have an efficient method to be adopted for their activities. So by doing the energy conservation at different levels, at the end user like homes or buildings or industries, you have benefits like reducing your energy bills, good comfort levels you can attain with the smaller energy, and increasing the productivity and reducing the maintenance costs, and increasing your profits by reducing the electricity consumption. These are the benefits which one can look. And at the national level, we have import fuels will come down, because most of the islands have been importing the fossil fuels. So the import fuel bills will come down, and improvement in the infrastructure by doing the means the same infrastructure can be used with lesser energy. If end users are consuming, same infrastructure can be used by the others, and additional power demands can be met, and NDCs of climate commitments, the CO2 emission commitments, what has been made by the individual nations, can be met by energy conservation. At the global level, this whatever the actions at from the home to the national level we have taken, it will reduce the greenhouse gas emissions and maintains the sustainability across the globe. Now, the energy management, we have various methods, use of less energy for carrying out the same level of work or activities and services, which we need to look as like a wastage of energy if it is there, which need to be minimized as a first step. And minimum energy consumption, where the requirements of energy is been there, which need to be rationed, and minimum energy maximum output to be achieved. And energy intensive processes should be minimized, which should be eliminated, you can say. And the energy management, whatever is there, it's not a one-time activity. It should be reviewed periodically. It should be taken maybe like every month or quarter or a yearly basis or a 3 years basis, depending upon the size and the type of energy intensity which we are doing. So the energy efficiency and the renewable energy, there are two different aspects. First is the energy efficiency, whatever the extent possible, use the minimum energy. Then we can have a renewable energy integration possible opportunities based on the location, based on the type of activities. We can see extent possible renewable energy, because the renewable energy is more expensive compared to the energy efficiency applications and retrofits. But both are two pillars for the sustainable energy for any of the institutional level. Now, coming to the energy audit of a home, if you can see that there are different steps, we have different methods, components which are there in the energy audit to do. So individuals, if they can understand how it should be done, the methodology, the pattern of doing the energy audit, it will be easy. And definitely if they can perform their own energy assessments for their houses and the schools and the colleges. So Primarily, when we are starting to take up the energy audit, what one need to do is to collect the basic information. Why we are doing the energy audit? One need to ask a question for themselves. Then what information to be collected for that particular building. And the information mainly for the homes, what we'll have is electricity bill, that is the utility bill will be there, and a number of people, size of the building, the type of facilities, how it is, what kind of building. So the basic information to be collected, and the base load of appliances, what are all the equipments are there. You can list down all the equipments, including the lights, fans, computers, laptops, TV, all the appliances you can take. Then you can have a rating, the kilowatt, which I told a tag, which will be there, or the nameplates if it is there, or based on the size, the model of the equipment. You can even type the model in internet and you can get the wattage of that particular appliance. That kind of a preliminary review one can do for their home. Then once you listed down all the appliances, then you can have a quick assessment whether the appliance model and that size of your appliance is an efficient one, or there is some more for this doing the same type of work or same type of purpose of application, whether you have a better equipment or low consumption equipment available in the market. You can do that quick assessment. Then you will know whether the appliance what you have is efficient, or there is a much higher efficiency equipment is available in the market. So that is a preliminarily, quickly you can do that assessment. Then you will know us there is a potential is there by doing this particular assessment, thorough review. I can do some energy savings is possible at my home or school, kind of one can decide. Now, the second step is after the preliminary assessment, you will get to know what are their equipments and appliances. Then you can have a quick visual inspection of the building and the key systems, what they have, like electricity they are using, LPG they are using, charcoal they are using, water they are consuming, which are all been billed, how the billing has been done, electricity bill is coming every month, utility bill, those kind of data, water, whether they're procuring the water every 2 days or monthly bill is there from the utility. LPG, how is it a cylinders they're buying, how many cylinders per month or for a quarter they're buying. That kind of quick assessment on the data can be done, and the visual inspection where they are using, whether hot water geysers are there, whether how many bathrooms are there, how many places the hot water has been used, whether bathtubs are there, or whether it is only showers are there. So that kind of preliminary visual inspection can be done. And interview with the occupants, mainly the interview with the occupants is like children, how many hours they do use the TV, and the elder people, how much time they use the TV, and washing machine, how many times in a week they use, or every day they use, or how they are using, what is their practices. This kind of questions one can ask with all the family members and the occupants of that particular house, or if tenants are there, they can take from them. And even like outdoor lights, how much time they use, or every day for the security purpose, they're switching on the lights and they're stopping at the evening hours, or switching on morning and switching off at the evening hours they're doing, or continuously lights are blowing, or there is a photo sensors are there, which takes care of the outdoor lights on and off. So those kind of things one can visually see, and you can talk to the people how they are operating. So that calls for an interview with the occupants. And immediate energy saving measures, when you are discussing, when you are seeing physically, you can see that where there is a potential for possibility of energy saving. Probably one example we are seeing in many buildings in Grenada also, where they have a outdoor perimeter light, where controlled with the photo sensor, but the photo sensor is kept under the shade. And because of the shade, continuously the light has been blown. It is even the power consumption is there, electricity consumption is there. The control device of solar photo sensor is there. but still the location of the photo sensor where it is kept, which is blowing the lamp continuously, that is immediately saving, where with the switch they can control rather than controlling with the photo cell, disconnecting the photo cell, they can operate through the switch itself. There is a like immediate energy saving measure. So you can assess based on that kind of examples. And data, whatever the information has been collected, like electricity bills, then you can correlate that particular room or the area, how it has been utilized, that data with the energy consumption of that particular building, and the summing up of all the equipments, operating hours and kilowatt with the energy bill. That kind of analysis one can do. Analysis can be extended, whatever the extent it is possible. It can be done based on the amount of data what you collect. You can do, even you can assess, like because a particular month in the house only the 4 members are there, the energy consumption is less, and during the holidays 2 more members are being added, then the energy consumption is high. That kind of analysis one can do. Then where there is a losses are taking place, if the heat losses are there or leakages are there, where the doors are not properly insulated, or there is a leakages are there where air conditioner are used, that kind of more analysis with in terms of heat loss, in terms of amount of airflow and carrying the heat, those kind of analysis can be done. And then you can see the potential improvement opportunities by doing what we can save or what we can plug that losses which is taking place in the system, that can be defined. Then develop the list of energy saving measures, opportunities which exist across the equipments as well as the systems what in and around the home. Then based on, once you have listed down the energy saving opportunities, then we can have a cost benefit analysis by having the investment cost can be drawn from the market for that particular equipments to do retrofits or assessments kind of one. Then based on that, you can develop an action plan, which measures to be implemented based on the cost, less cost and more saving. You can define first priority, the second priority, or one for the 6 months, next 6 months we can do, and maybe after 1 year, or when I am replacing the equipment, I can go for high efficiency. That kind of decision can be taken as an action plan for implementation of the measures. So these are the components of energy audit. Now, if we can see a typical energy bill, there's how this is a Granida energy bill, but most of the energy bills will be the same, like where you have a energy meter reading of the present month and like a month of March and April. Then the difference between the 5955 and 284, which is nothing but 91 units for a period of 30 days of thing. And you have the cost components like non-fuel component and fuel component, depends on what are the cost of a total utility fuel bill and the amount of energy has been generated. They will decide on the cost. And non-fuel component is mainly for the HR, operation, maintenance, and all those costs which are being operated by the utility, divided by the units of generation, they will define. So both these costs together, it will become electricity cost. That is like in this particular case, it is $75 East Caribbean currency is $75. And it is a very good example. This particular bill, if you see, we have previous 8 months, apart from the current bill, they try to give in the same bill the previous month's bills, and we can see how many days this particular bill is and what is the energy consumption. So even if you can see in the month of January for this particular case 29 days, but which is 122 units is consumption for 29. So the average, if you can see, which is varying between the 2 units per day to 4 units per day, kind of as a monthly average. So it includes the holidays and as well as the working days and all. But there is a difference. What could be the probable reasons and other things one can even assess. So basically once you have a bill, then you can correlate with the rating of the equipment what you have, and define the major energy consuming equipments in the particular set of house, small consumers and large consumers, we can define. Then what is the cost, unit cost of energy? That is a very important. Sometimes what happens, even the units will not rise, but electricity bill comes higher because of the fuel cost may rise. Then the input fuel cost, due to, as we have seen Mr. Aswath was telling, due to the war, the fuel import bill has increased, but your energy consumption may be same, but because of the rise in the fuel cost component, the overall bill may rise in some months. So that one can very specifically study what is the unit cost, what is the components, but very specifically for energy audit or energy conservation, the KWH is a very important parameter rather than the cost. Cost is important, but the variability, you can see whether the cost is varying or not, but the more variation of your energy use is basically defined with the consumption as a KWH.
One second, Dr. Rao, just to, because it's quite important that I intervene here, just to summarize where we are so far. So we looked at energy efficiency versus energy conservation, and we understood energy conservation to relate more to your habits, to your behavior, the things that you can do. While energy efficiency relates to a change in technology, using a more efficient product, using a more efficient lighting, changing from incandescent to perhaps a LED bulb, that will be considered energy efficiency. While energy conservation would be to turn off the lights, not leave them on all day. And he will have used an example with the washing machine and ironing and so on as habits. Where we are now, we're speaking about collecting the data in your homes. And he's explaining to you that when you look at your utility bill, not to look at it in terms of just the dollar figure, because normally in your utility bills, you will have had a non-fuel component and a usage component. And that non-fuel component is the component that you'll be looking at in terms of that's what the utility will be charging you, while the fuel component is dependent on the import of fuel into the country that is dispersed amongst the citizens. So the one that is variable normally is the one that is the fuel component. But what you really should be looking at is the number of units consumed per month. And then you'll be able to determine if you're being energy efficient, if you're being conservative or not. So you actually should be looking at the number of units and not necessarily the dollar amount that you're spending each month. I just wanted to intervene here. I know some of the participants, you're unable to speak on the mic and ask questions. And I encourage the participants to use the chat to pose the questions if you have any. Okay, go ahead, Dr. Rouse. Sorry again.
Yeah. So now we have the second step where after the collection of the energy bills, data collection, we can have a visual inspection where we can see the measurement of the lux using the lux meter, and we have a different audit instruments where it can be used for measurement of the temperatures, measurement of the sound, and even the dry bulb temperature, wet bulb temperatures, and the flow meters for the water, and the speed of the equipments, fans, and other things. So using these equipments, we can collect the information, which is operating information of the particular building, or a particular room, particular appliance. Then we can have conduct a test and trial runs where for the air conditioners, if we have, where we can increase and decrease the temperatures and see the power consumption, how much it is taking. It's really working. Compressors are getting off and on. If the temperature set is kept at 25 degrees, the compressor should get off. So whether it is doing those kind of tests and all can be carried out during the field visit. Then we need to look into the maintenance practices, how they are cleaning and how the particular machines are being located. And even like you can see the simple example of maintenance is the gas stoves. When you are using the gas stove, there is a carbon deposits will be there. 6 months once cleaning, 3 months once cleaning will be prescribed by the manufacturers when you are buying. So following that practice, you can clean so that the burning efficiency will be good for the kind of flame what you set. So those kind of maintenance practices, even for the pumps and other things which we use, even the lighting even the where there is the insects are been there inside the luminaires, where the light has been obstructed or water has been clogged in the lamps. So those kind of things also one can visually see and note down and put it up across so that those things can be taken up as a implementation. Then interactions with the operators, if there is a school is there, then you can talk to the operator or security who is switching on, switching off, UPS systems, computers, how they are running, even the occupants of the building, how their behavior when they are using the equipments very specifically, what kind of control is there, whether it's a manual control or photo sensors or the motion sensors. Those kind of information should be collected while data collection from the sites. Then once the data has been there, which need to be analyzed in a specific manner, if you have collected all the energy bills, then you can see what is the variation in the monthly bill, then section wise consumption, equipment wise consumption, you can define. Then you can have a performance assessment, whether whatever the input you are given, power for the particular appliance, the output what it is giving as per the standards, as per the manufacturer nameplate, we can verify those. And if there is any deviations, then you need to identify the deviation, why that deviation is happened and what kind of losses are taking place, whether those can be recovered or it is non-recoverable. That way also one can make an assessment. Then once the analysis has been done, then take a call on the measures, whether the measures can be like changing the operating parameters or by a loss reduction, by minimizing the airflow rates, adjusting the airflow rates. Those kind of loss reduction mechanisms, methods can be defined and listed down. Then retrofits, by keeping some kind of a retrofit to control probably the energy consumption or a number of operating hours of the equipment will come down. That assessment and analysis can be done. And if the equipments are old and burned out and several times it has been used and which is not operational or due to anything, then replacement of the equipment. Whenever we are procurement of equipments, you can see, look into the high efficiency equipments available in the market. Those assessments can be done, what particular equipment you're looking and what efficiencies are available, kind of one for before replacement, and you can take an correct call. Then you can have a change in operating parameters, like a simple one is changing the air conditioner temperatures up and down, increasing and decreasing. Then you can see the what is the energy consumption, real energy consumption is happening by connecting the portable instruments. If the motors are there, if it is all underloaded, then you can have a star delta converters and shifting of equipments based on the loads and other things can be done. And hot water boilers, if it is there, temperature settings can be made and adjusted the temperatures to optimum level. So these are the few measures. Then once the energy saving measures have been identified, then estimate the savings and other related. Assume that you have a water pump where you are introduce the level controller, where you are not only saving the energy by minimizing the water consumption, where the tank level has been reached, then automatically the pump is going to get switched off. If the level controller is not there, the pump has been operated till the overflow of the water will spill over, then you will hear the noise or something, then only you will go and switch off manually. So that is the water wastage. When you are doing the energy savings, There could be a indirect other material loss, material wastages and other things also you may be minimizing. So that also can be taken. Then estimate the cost savings due to the energy saving and the other productivity improvements and the material loss reductions. Those all put together, you can assess the cost savings. Then estimate the investment required for the intervention so that the investment, whatever you have done, will be receiving you back with the correct attractive payback period. So once you know the investment cost and the operational cost of the savings, then we can calculate the payback periods and the return on investment period. Now, as the steps, whatever we have seen after performance of all the steps, then the report making is one. And before report making, you can categorize the total energy saving measures based on the time period and recovery as a short-term, medium-term, and long-term measures. And you need to identify the equipment suppliers for each of the measures, whether they can visit your home or office. Then they can suggest what kind of measures can be implementable, what it cannot be implementable based on the structure of the building or roof of the building, various conditions, preconditions they can define. Then you can decide on that which measures can be taken up, which measures cannot be taken up. Then you can allocate the budget for implementation of the measures. So in any place, the best method is first you have to identify the operational change and the behavioral change, how much energy, minimum energy one can consume and do all the operations in the building. So energy conservation is the first step in when you are taking up the energy conservation study or energy audit. Then once your energy conservation measures has been listed down, then you can look into the opportunities where there is a technological change, where high efficiency can be, equipments can be integrated, where with the minimum energy you will get the more output, or it will solve all the requirements of the energy demand, energy consumption inside the building. Then once you are minimized the energy within the building, then you can look into the option of renewable energy integration, so that without doing energy conservation or energy efficiency, if you directly go for a renewable energy integration, the capacity of the equipment, cost, everything will increase. That is one of the high investment proposal. So one has to look always the energy efficiency, energy conservation as a first priority, then going for the renewable energy integration as a second step. So any specific questions or anything till here from the participants? Is there any questions or any clarifications before moving to the next session? So, so understanding the different components of energy bill, we are discussing, we are seeing the energy bill and the components, but various components of electricity bill will be fuel charges, the cost of the fuel, then non-fuel charges, which is the O&M cost and the operational cost of the utility, as well as including the profit on the units or profit levels. Then a non-fuel rate into units. So here, if you can see the once the fuel cost is there, multiplied by the units of energy consumed by that particular end user house, if you multiply, you will get the cost towards the fuel charge and non-fuel charge. Then RE charge. RE charge is if the utility is set up a new investment as a RE, renewable energy, solar energy, there will be a charge for that one also. The total units, whatever has been consumed, there's some amount of small charge of RE also will be there. And there is a VAT, which is a value added tax on the units, non-fuel charge units. They can have a fuel, no additional cost towards the taxes. Now, these are the various components which we have seen, like the fuel rate. If you can see, the 0.42 is a fuel rate and non-fuel rate is 0.40. Then we have a units then the units multiplying with the non-fuel and fuel, you will get the total charges 36.9 and 38.52, and the total of both, if you can put together, it is a 75.44. So this is how the energy bill. Now we have variation in the energy bill. When it can happen, if the number of people in the house are more, are utilizing the electrical appliances more in terms of quantity or in terms of usage, the long period, instead of using the TV for 1 hour, if a good movie is there and if you are using for 2 hours, then definitely the energy consumption of the particular equipment will be more. Increasing the number of activities due to the special occasions, festivals are there, carnival is there, where a lot of people are coming together, then the energy consumption will increase, or that particular period energy will be high. The faulty installation of equipments, where it can lead to the burning of the equipments, and poor installation, as well as consumption also. If you have aligned equipment, if some mixie or something you are using, where it has not been installed on a plane plank, where there is a inclined plane you are equipped, and then it's a faulty installation where it can turn down, or the plugging water will spill into the electrical, then short circuit. So those kind of things also sometimes lead to the high efficiency, the higher energy consumption. Then the billing issues, where the taxation and other things, if it has not been done, or downloading of the bill has not been done properly, multiplications, so issues with the errors kind of one, that also one need to check. Increase the number of appliances. You must have been brought from the office 2 extra laptops, and you must be using during the weekend, then that also can cause the increase in the consumption. So one has to, there could be several means and ways why the energy has been increased in some months, and why it has been reduced. You can see like this, if the monthly bill it is coming, and some month it is a 57, and most of the months it is 84, 91, but some month it is less and some month is high, then we can ask a question that why it is more or less kind of one. Now, once you are listed the quantity of the appliance in the house, like a television is there, fridge is there, washing machine, 1-ton air conditioner, smaller air conditioner, LED lamps, outdoor lamps. So you will have a quantity in that particular house. Is it a 111 number, and 3 LED lamps are there, outdoor lamps are 2 are there, and it's a nameplate wattage. What is the wattage of the equipments, and operating hours per month. If you are having like 120 days, 250 days, 30 days, 50 days. So once you have a quantity, wattage of that particular appliance, and the operating hours per month, if you can multiply A, B, C, then divide by 1000, because these are all watts. Watt divided by 1000 only will give the kilowatt. So you can define what is energy consumption. Then the total energy consumption is 122.8 for this particular house. So you can verify 122 from the energy bill, why it has come. Okay, 122 is there this particular month, and my usage is like this, all the equipments kind of. You need to do a balance of the energy, and it may be not necessary always it will be close, but even the 2% variation, 3% variation is considered to be a very good number in the balancing of the appliances and the usage. So,
Dr. Rao, before
yes.
you move on, just can you go back to the previous slide?
Yeah.
I just want you, if possible, can you walk us through the process of collecting this information? So we walk around our homes, we identify the quantity, the nameplates, and if you could just walk us through the calculation a little bit slower so that we can understand this.
So it's basically like you have one television in the hall. When you do a visual inspection, you can note down television, one number is there, and you can see behind the television, you have a wattage. It is like a LG or a Samsung, then you will have a model of that one, and then you have a wattage, 50 watts, it will be written. And you can, during the interview discussion with the family members, you can assess that every day we use the television for 4 hours. Say like morning 1 hour we are using, and evening we are using for 3 hours between 6 o'clock to 9 o'clock. Then it is every day we are using the 4 hours into 30 days. 4 hours into 30 days is like 120 hours per month. So when you have hours, you have a wattage, and you have a unit is one number of TV. So multiplication of 50 watts into 120, which will become 6,000. Then 6,000 divided by 1,000 is a 6 watt. Similarly, the fridge, generally a house which will have a bigger fridge of based on the rating. You have in the front label also will be there, star rated label, what is the wattage of your particular fridge. Then you can multiply that one with the operating hours. If you can see the fridge normally, which will run continuously, and on and off it will be there. So in case if you want exact operating hours and the wattage, even you can plug the energy meter, single phase energy meter to the plug, and you can insert directly, you can get the wattage, and even the hours we will get, and watts we can get. So multiplication of 120 into 250, we can get the wattage. And the washing machine, you can see here the wattage of the washing machine is 400, is almost like 0.4 kilowatt, but the operating hours is only 30 hours. Maybe like you can say every day 1 hour you can use, maybe they're using like 1 hour, then 30, or you can say 3 hours, and only during the weekends of 10 days, Saturday, Sundays, they are using, then it will be like a 30 hours kind of. And air conditioner, which will be operated only for 2 hours in a day, during the evening hours kind of one, you can calculate. And wattage, actually the 1 ton air conditioner rating will be like 1.2 kilowatt or something, will be written on the nameplate. But actually when we are measuring based on the setting, what we have kept as the low fan speed, medium fan speed, high fan speed, we can get the wattage. Then it will be like medium wattage is 800 watts. So 800 into 50 hours of operation, we can get the actual consumption of that particular appliance. Then we have a LED lights. Maybe you have 3 rooms which are there, and the operating hours will be like a morning 4 hours, 8 hours per day, or morning and evening they are using based on the time period. And the wattage of each of LED lamp is 15 watts. Then we can multiply with the quantity and the hours, we'll get the wattage. Outdoor lights, like evening hours, it must be running continuously, like evening 6 o'clock to the morning 5 o'clock. That is around 10 to 11 hours it will come. So multiplied by 10 into 30 days, 300 hours. And the wattage of the lamp, each lamp is 40 watts, which is of 2 numbers, 2 into multiplied by 40 and 324 hours kWh. So adding up of all the appliances and the operating hours, we are trying to evaluate what is the total consumption. Then we are verifying this consumption, what we have done, measure calculation. We are verifying with the actual bill, monthly bill kind of one. Now we have a fuel different tariff, the electricity bill. We have a fuel charge and non-fuel charge, and the number of units and the VAT. VAT has been applied for the non-fuel charge on a monthly bill for above 99 units. So our units of consumption is 122 units. So non-fuel charge is 0.4057 multiplied by 15%. So the total fuel bill, non-fuel bill, units multiplied by the cost, and here the VAT calculation, then it has become $112 as a total bill amount. Now, in this particular case, just as an example, if outdoor lamp, which we have seen as a 40 watts lamp, which is there, has been replaced with solar lamp of 20 watts LED battery backup solar lamp, so that consumption of that particular MH lamp, which is there, which has been zero. The monthly, from the monthly bill, outdoor units consumption has become zero, because you are replaced this whole particular MH lamp, metal halide lamp, with the solar LED street light. So 24 units the consumption which is there. If you can see from the previous outdoor consumption of the lamps is 24 units, which has become 0 now because we are integrated with the solar lamp. So the total units is 98.8. So now what will happen when the 98.8, there is no VAT.
Dr. Barrow, if you could go a bit slower in the when you're doing calculations so that the participants can have an opportunity to understand. I know it is technical, and it is quite easy when you're technical to think it is simple, but we have a lot of non-technical people who may want to understand what is happening. So if you could just slow down a bit, thanks.
Now you can see the previous slide where we have a total electricity bill, which is calculated with the fuel charge, non-fuel charge multiplied by the number of units. And we have a fuel charge, and units multiplied by non-fuel charge, and we have a units with the number of units multiplied. VAT is nothing but 15% of the non-fuel charge for a monthly consumption of above 99 units. If the units is above 99, then only the VAT will apply. So here our consumption in the initial, when we are using the metal halide lamp, our units is above 99, 122.8. So the VAT has been applied and it has become 112. But when we are replaced this particular outdoor lights with the solar lights, our energy consumption is below 99. It is a 90 to 98.8. So now if you can see the calculation, only we have a fuel charge and non-fuel charge. The VAT has become the 0. There is no taxation for the below 99. So in any most of the countries where there is a slabs will be there below 50 units, below 100 units, certain categorization where there is a taxes and other rebates will be provided by the government, where the minimum energy consumption, if you are doing for a house, you will be the lower tariff benefits you will get. So in this particular case, the VAT is not applicable for the units consumption below 99. So that benefit we are taking, then revised calculation after the installation of the solar outdoor light, it has become 84.1 from the $122. So the reduction in electricity bill is 28% from the investment of solar lights, where the 100 East Caribbean dollars has been investment, and the savings in the bill is almost 28%, because we are completely eliminated the electricity with the solar street light. So the energy conservation measures, a few measures, how one can calculate. As an example, I am given here. Tomorrow we are going to see more detailed calculation of the appliances and other things. Now, if you can take this particular case where the fluorescent lamps has been replaced with LED, where many people are doing, where in the houses, even the schools, college, everywhere, there is a lot of fluorescent lamps has been replaced with the LED high efficiency lamps. So how one can do the calculation? If you can see, there is a 4 lamps are been there. Assume all the 4 lamps has been replaced with the LED lamps. The wattage of the lamp, each lamp is 36 watt, which is standard wattage. And you have a choke, which is electronic choke, that we are not taken here, the consumption of the choke. But you are having a 36 watt lamp. When if it is blown, when you are on, it takes 36 watts power. Generally, the lamps will take full power kind of whenever they are operating. And assume that this particular lamps are operating every day 8 hours, like morning 2 hours and evening 6 hours, from 6 o'clock to 10 o'clock or 12 o'clock they are operating. Then if these lamps are replaced with a 20 watt lamp, then the energy consumption per day, if you can take 4 multiplied by 36 multiplied by 8 divide by 1000. 1000 is conversion of watts, because this is in watt. When you want kWh, you should divide by 1000. So it is 1.15 units for these 4 fluorescent lamps. When you are replacing this one with the LED lamps, the consumption is 0.64. So in a year, if you see, you have 365 days, and the energy consumption per year with the fluorescent lamps, which is a 420 units, and whereas with the LED lamps, the same is 234 units. So the reduction in the energy only by replacement of tube lights of 4 numbers with the LED tube lights, we are getting 186 units as a saving. And if you can see, yeah.
So just to explain to the participants. So when you look at a utility bill, the unit that is normally shown on your utility bill is kilowatt hours, kWh. And that's the number of kilowatts that you consume in that 1 hour. So what he is doing here is, if you look at your bulb, your regular light bulb, you will see 36 watts. So he's converting that watts into kilowatts, because that's what you normally see in your utility bill. So if you have 4 bulbs, you will multiply that 4 bulbs by 36 watts, and then he will determine how often you use this bulb. And in this particular case, operating hours is 8 hours. So it will be 8 times 36 times 4. And then he divided by 1,000, because a kilo is 1,000 watts. 1,000 watts is 1 kilo. So he has divided by 1,000 to convert it into kilowatt. So I was just explaining that process.
So now we have a cost, the unit cost for 1 unit, $0.78 as a unit cost. So to get a savings into the cost savings, energy savings into the cost savings, just we are multiplying this one with 0.78, then we can get from kWh to the dollars. So $145. Then the cost of the lamp, LED lamp, each lamp is $30. So we are multiplying this one with the 4 lamps we are replaced. So it will become $120. So the payback period, which is nothing but the cost savings what we have got, and the investment divided by the savings, which will give 0.8 years, which is nothing but less than a year. The saving which we are invested, our money will return back in this particular case. Now, same way, assume you have where in the school you have a fluorescent lamps for a corridor, where you are trying to replace this one with a motion sensor, where nighttime there is not much movement will be there, but there is an option that you can switch off alternate lights for certain amount of period during the night. So you are not changed any of the lamp, fluorescent lamp only is there, but the same lamp, by keeping a motion sensor, you were able to bring down the operating hours of the total operation, where 10 bulbs are there, alternate we are switched off, assume, then it will become 5 lamps for 15 hours and remaining 5 lamps are off. But there is a movement of the people where some lamps are getting on for some more time. So the total operating hours has come down from 15 hours to 10 hours. Then if you can see the amount of energy consumption with and without motion sensor is a 5.4 units, whereas come down to 3.6 units. And for a year, when you multiply with the 365, the consumption will be 1971 units. And with the motion sensor, it is only 14 units. So the overall reduction in a year, for a full year, it will be 657 units. Then in terms of cost, it will be around $512. Then investment for the motion sensor will be like $80 if we take. And the total investment for the different locations, alternate bulbs are there if you want, then the investment can be 800 for 10 sensors if you are keeping kind of one. Then the overall, the payback period will be like 1.5 years, 800 divided by 512. So this is for reduction in the operating hours kind of one. Then now we have a replacement of air conditioners. You have air conditioners of non-inverter or window ACs for 1 TR machine, where the nameplate will be there as 1.3 kilowatt or 1300 watts as a wattage. Now, when you have measured the power consumption of a machine, it can take old machines which will take full power of 1220, and whereas the inverter-based air conditioner will take slightly lower power based on the type of compressor what we have. Generally, it will be 1 or 1.1 kilowatt. So the operating hours of inverter AC, it based on the temperature set where it will on and off or switch off to the lower speed and then high speed kind of. So the overall operating hours, which is 15 hours with the old non-inverter AC, where the same with the inverter AC, it is around 10 hours of operation of the compressor. So the overall, if you see the energy consumption of old air conditioner is which is consuming around 54.9, that is around 55 units, which has come down to 31.5 units kind of. So if you are operating this particular air conditioner for 300 days, only during the working hours, we are operating, then the savings, if you can see the difference, which is 16,470 units, which has come down to 9,450 units with the high efficiency inverter air conditioner based air conditioner. So the saving potential is 7,020. Then we have the cost savings multiplied by the units of energy, that is dollars per kWh, it is a 5,475. The cost for the new air conditioner is $300. And 3 units, 3 air conditioners we are calculated. So it will be 9,000 divided by 5,475, which is 1.6 years is the calculation. So here, if you can see, the operating hours are less with the high efficiency inverter, and the actual load draw also is slightly lower than the conventional non-inverter based AC. So these are the 2 parameters which is resulting in reduction in the energy consumption. Same way we have say a water pump with the level controller, where we have water pump which is rating is 7. Actually here it is one pump only, it is not 3, it is 1, and the consumption, if you can take, it is 5 hours has been operated by the pump without the level controller. And using the level controller, assume that we are dropped down by 1 hour of extra operation, then the consumption will come down from 3.5 units to 2.8 units. Then the energy savings, if you can take 1,277 to 1,022 units. So the savings is use of level controller for a pump of 750 watts. By 1 hour reduction, we can get per year around 255 units of saving, which is results into $199. The cost of level controller will be like $100 with the very minimum. So one level controller, one pump only we are used. Then the payback return on investment is almost like a half 0.5, that is within 6 months period. By using the level controller, the amount of savings of 255 units which we can save, the return on investment is only 6 months. Then the other scenario where we have a fans which can be replaced with the high efficiency fans, that 75 watt fan, which is conventional fans, which is the 60 watts is a load when it is switching on with the different speed settings, whereas the BLDC fans, which is 30 watts fan, which can be used for 28 watts actual loading of the fan in this particular case, where the operating hours is 12 hours of operation. So the units consumption is 3.6 versus 1.68 units. For the operation of 300 days, we can get 1080 kWh to 500, almost half of the energy has been saved. So with the cost is a $450 is a saving, and the cost of the BLDC fan is $150, and the 5 numbers of the fans is $750, and the investment, as it's a technology change from the conventional fan to the BLDC fans, the investment is slightly higher, and the payback period in this particular case is around 1.7 years. Then we have another example which we discussed, like same like street light, where we have a conventional street light which is there for perimeter, and which has been 140 watts, which is replaced with smaller rating lamp with the solar kind of one, or LED street light, solar LED street light kind of one. The consumption, if you can see, conventional lamp with the LED kind of one, and here the less than 1 year is the payback period for this particular case. So once you are assessed the payback periods, you can have a action plan to draw short-term measures where the payback period is less than 1 year. You can see all the places the payback period is less than 1 year, where there is an investment, high investment, and savings is there, where the payback period is less than 2 years. You can categorize them into the different measures. Then based on the budget availability and which is the priority, you can draw with the consumption. So these are the some examples for the calculations and other things. So if any questions, anything to be answered? So then I will go to the two simple questions for what we have done today. You can answer. I will give for a half minute for each question. You can put in your chat box also.
A question. If you look in the chat, Dr. Raro,
Yeah.
There's some questions. How do you get the 0.78 on the annual savings?
Okay. Well, 1 minute. Yeah. Okay. Now, if you can see the energy bill, here we are taken as a 0.44 and 0.5. These are the two as the latest one. Together it is a 0.84 is the unit cost. Okay, this is how the cost, but whereas we are taken 0.78, which is the old energy rate, which is a mix of fuel charge plus non-fuel charge. Actually, here the bill, if you can see 0.42 and 0.40. These two, if you add, it is a 0.82. Same, you can see there is a fuel charge will continuously varying, 0.42, 0.44 like that. So the same, these two, what I am considered is a old bill, 0.78 has been considered for the calculations purpose. You can see here current electricity charges, it is a 75, it is a total. This is not related to this one, but this is how we are got. Here it is.
Hello?
So when the old fuel cost is less, say it is 0.38 and this is 0.4, 0.78 is the cost of the unit.
If possible, I have one question.
Yeah.
Thank you, Mr. Narasimha.
Yeah.
The electricity cost rate is based on the flat rate that you have it is a flat tariff. But if we have the other model of tariff like that rising with different categories,
yes,
how's the solution for that one?
Yeah, you can take it as the average cost. What you can do for a particular month, you can take total bill amount divided by the units.
Yeah.
Yeah, then you can get the cost for that particular month. If you want further fine tune, average of the last 12 months, you can do then add up and divide by 12.
Yeah.
Yes.
Thank you.
Yeah. So what is the important parameter for the household home energy audit when we are doing analysis of the monthly energy bill? So here so the KWH is the answer. Now we have seen in this particular case of example, the applicability of the VAT and levy. I told you units above in a monthly bill will apply. See, that is a very important parameter for this particular bill, which is 99 units and above, the VAT is applied. And it depends on the location and the utility. What is the minimum KWH for the consumption? Now, this is another question. Is it an replacement of a solar-based LED for perimeter lighting for a houses, whether it has been energy efficiency measure or energy conservation measure? So there are many people are given it as an energy efficiency measure, but if you can see, it is a LED. Use of LED is definitely as a high technology energy efficiency measure, but the house which is adopting the solar, it is a practice what the behavior they have changed from the high efficiency. They're using the high efficiency LED with the solar. So it is nothing but the energy conservation, which is habit, which is the adaptation. No, they're practicing. They're changing to the solar LED. Conventional fuel, they're taking it out, and high efficiency integrated with the solar. So it is a energy conservation measure because it's the habit, the adaptability of the home. Then assume that you have a refrigerator. Refrigerator is very common in your home, where the efficiency of the refrigerator, the old 10 years old refrigerator is there. If you are going for the new refrigerator, which consumes less energy or more, what is your view? Refrigerators which has improved over the last 10 years, though the new refrigerators consume less energy or more energy? Less energy. Yes, it consumes less energy because over the last 2 decades, almost the 30 to 40% of the refrigerators energy consumption has come down. Then home energy audit needs the discussion with the family members. Is it required or not required? Yes. Yes. So these are the simple questions based on our today's session and interactive session. So tomorrow we're going to have, these are the topics for tomorrow. how the energy consumption has to be assessed, identification of the saving measures, and how to shop the equipments, the new appliances and all, and the basic savings calculations and the energy saving measures, which we'll discuss in tomorrow's session. So anything for today's?
Thank you, Dr. Rao. And tomorrow we'll, as you said, we'll dive into identifying and assessing our home environment and recognizing what are the high consumption items, and we'll be looking at how we can do our own home audit. So tomorrow's session will be quite interesting, and I'm hoping that everyone who participated today will join us tomorrow. I want to thank the participants for taking time out. We had a good session this morning, and I want to thank the IRENA staff and Dr. Rao and his team for the presentation today. And we'll conclude today's session. I wish you a good balance of your day and night, and see you tomorrow. Thank you.
Thank you, Michelle. Yeah.